Hi, everyone. I wanted to give you another example of a really complicated mess of resistors and show you how to work through those details. What you'll see here is we have a 12-volt uh, battery connected to a wire. The wire then breaks off into a junction. The top of that, the top wire out of that junction goes to a 7 ohm resistor, and then that runs into another junction that runs into an 8 ohm resistor. You can also see that the bottom of that junction wire comes in, meets another junction, breaks off into a 2 ohm resistor in series with two parallel resistors, a 4 ohm and a 3 ohm. And the top of that junction runs off to a 5 ohm and a 6 ohm in parallel, and then rejoins back just before we hit the 8 ohm resistor. After the parallel bank, the wire comes back to make another junction with the 8 ohm resistor, and then that wire goes on to run into a 10 ohm resistor, and again, that's a 12-volt battery. So what we're going to try to do is work out the details of basically how to work out the total equivalent resistance of the circuit. Once you have that, you could do things like determine the voltage at a particular spot, determine the total current coming out of the battery, because, as far as the battery knows, the equivalent resistance is really what's going on. So once you figure out the equivalent resistance, you just have a V equals IR problem. So let me show you how to do this. First off, what I'm going to do is break this part of the resistor that has the innermost parallel circuit. I'm going to go ahead and replace those with a single resistor. So what I'd say is 1 over R parallel is equal to 1 over 6 plus 1 over 5, which is equal to, of course, 5 plus 6 over 30, which gives you 11 over 30. And that means R parallel, in other words, the single resistor that we can replace these two guys with, is going to be basically 30 over 11 ohms. But of course, 30 over 11 is not that helpful. I'm just going to use some quick arithmetic and realize that R parallel would be the exact same thing as saying 33 over 11 minus 3 over 11. So that could actually work as well. If you actually work out 33 over 11, you know clearly that's 3.000. And then, of course, 3 over 11 is really not that complicated. But if you know your fractions, which I try to commit to memory, it's just 0.2727272727. So 3 minus 0.27 should be essentially 2.773. So I want to say that R parallel is basically 2.73 ohms, but I'll remember, of course, that it's really more like 7.272, so on and so forth. So that replaces that resistor. I can basically just do this and say this is now 2.73 ohms. Now I can also go ahead and get rid of this guy as well. So this R parallel is given by 1 over R parallel is equal to 1 over 4 plus 1 over 3, which obviously equals 4 plus 3 over 12, which is obviously 7/12. That means that R parallel is in fact 12 over 7. But as you know, 12 over 7 is not that easy. It actually turns out to be R parallel is 1 5/7. So 5/7, of course, 1/7 is 0.1428. So when you multiply 1428 times 7, you end up getting 0.7142. So this would be 1.7142. But trying to stick with three sig figs, I'm going to say R parallel in this case. So this is a slightly different one than the other one, so I'll give it a different symbol. That's going to be roughly 1.71 ohms. So we'll say this one's 1.71 ohms. Now that you have this guy and this guy figured out, you can actually realize that these two are just in series with each other. So I can just add that to get a new resistance for this one. So now my equivalent circuit will be, here's a little 12-volt battery. Here's the 10 ohm resistor. Still going to come up here, and now it's going to go off to this, and we'll try to keep all the junctions about the same so we can work out some problems that come up later. That's 7.0 ohms. That is in fact back here, and then up here we're replacing this with 2.73 ohms. And then that's in series with the 8.0 ohm. You'll notice I just tried to use a series of resistances, no two of which were equal, so it wouldn't be any confusion as to where it came from. Now this, of course, goes down to what was the 2 ohm and the parallel bank that we just solved. So I'm now going to take this 2 ohm and this parallel one, which we discovered was 1.71. I'm just going to add that to it and say the equivalent is 3.71 ohms, and that just runs back to the end of the 8 ohm, and then this runs back here to that. So this circuit is exactly equivalent to the one we started with, but it's a little simpler. Now, you might get a little confused as to what to do next, but it's not that big a deal if you just realize that we can sort of shimmy this wire right here around a little ways. Like all this is just wire, so we could just imagine this wire instead went straight from here to the 2.73 and then went straight from here to the 3.71, and you'd see that these two are in fact in parallel with one another. So now we have a R parallel, 1 over R parallel is equal to 1 over 7.0 ohms plus 1 over 2.73 ohms. And we really should carry an extra digit there. So 2.73, the actual digit should have been 2.7273. So 2.7273. And this, obviously, I don't know any fractions for, so I'm going to say this R parallel, and I'll call it double star so we won't get confused with the last one, which was a single star. I'm just going to work it out with a calculator. You do 1 divided by 7 plus 1 divided by 2.7273. Let's see. Trying to look for the delete. There it is. And now when I do that, I have to flip it over. So I take the reciprocal of that number, which was 0.50952. So this came out to 0.50952. But when I take the reciprocal of that, I get 1.9626 ohms. So I'm going to call that 1.96 ohms. So now we can replace these two with 1.96 ohms. So now my equivalent circuit becomes basically coming from the battery. I want to go up. I want to run into a 1.96 ohms. That is in fact in series with an 8.0 ohm. And those two are both in parallel with the 3.71 ohms that we previously calculated. And then they come together, and of course we'll run into the 10.0 ohm resistor and the 6-volt or the 12-volt battery. Okay. So make sure you can figure out how I can flip these wires around to make this the same as what happened there. That's sort of the key to figuring out some of these messy things. But now we see we have two resistors in series, but they're in parallel with this one resistor. So I can easily make this 8 plus 1.96. So this becomes 12-volt battery. That's the big side. Is going to go up. It's going to be in parallel with, or there's going to be a parallel circuit of 9.96 ohms in parallel with a resistor 3.71 ohms. And then that, of course, is going to be all in series with the 10.0 ohm resistor. So again, I do another R parallel. 1 over R parallel is equal to 1 over, all of a sudden it just went out of focus. Okay. And my handwriting got really bad. 1 over R parallel is going to be 1 over 9.69 plus 1 over 3.71. Again, I should really use the extra digit. So I really should call this 9 point, 9 point, whoa, I wrote that backwards. Let's kill that. 1 over R parallel should be 1 over 9.96, but I should use 9626 plus 1 over, and this time it's 3.71, which in fact was 3.7142. And that should give me R parallel, which I'll call R parallel IV. Because I don't want to write, 3. I should have did 3, but anyways, I don't want to write all those stars. So I'll do 1 divided by 9.9626. Again, I'm using the extra decimal places, 9626, plus 1 divided by 3.7142. That gives me 0.36961, but I got to flip that over. And the reciprocal of it is 2.705. So I'm going to say R parallel, which oddly I called 4 instead of 3, is 2.71 ohms roughly. So now I have this thing being replaced with 2.71 ohms, but that's in series with 10.0 ohms. So I'm going to say the R equivalent for the whole circuit, which is the question that we were trying to answer from the beginning, is in fact 12.71 ohms. That's our final answer. Now, realizing that that's the equivalent, what that tells us is if I had a 12-volt battery, it would not know any difference from all that junk that we had up here. It would not know any difference between having that and having this in series with a single 12.71 ohm resistor. And then, of course, since this is 12 volts, according to Ohm's law, we have 12 volts, V equals IR, by the way. We have 12 volts is equal to I times the resistance, which is 12.71 ohms. So in fact, we can get an extra little bit of information, just solving for the current, just to see how you do that. And I'll even explain where that current is in the circuit. So I'm going to say 12 divided by 12.71 gives me 0.944 amps. Again, I've just thrown sig figs to the wind in this whole calculation. Now what that means is that is exactly the current going out of the battery. So if you look at the original circuit, say right here, that's the current that's leaving this. We pretend like positive charges are leaving here. So basically 0.944 coulombs leave here every second. And notice a bunch of crap happens in the intervening period, but just as many come out as has to go back in. So that means that's also the current through the 10 ohm resistor. So from that, we can realize, oh, well, you know, if we're going to call this, say, 0 volts, and this is going to be lower than 0 volts by 0.944 times 10, and then we get the voltage that's right there, which is the equivalent of the voltage that's right there, which is the equivalent of the voltage that's right there, which is the equivalent of the voltage that's right there and right there, and it's also equivalent of the voltage that's right there. If we went the other way, it would be 12 volts, 12 volts, 12 volts, again, ignoring the resistance of the wires, 12 volts, all the way up to here, and then 12 volts right here, and then 12 volts right here, and then 12 volts right here. So taking that apart, we could actually bit by bit figure out what all the voltages are, what the currents going through everything are, but that is obviously a nasty, ugly problem. So the final results, just to remind you, for all that mess, again, you should draw this, be able to make sure you can do it on your own, but for all that mess, the equivalent resistance is 12.71 ohms, and if you want to calculate the current the battery would deliver, it'd be 0.944 amperes. I think that should do it.